Homework 1 is on graphing exponential functions. All right, so the first ones, when we say sketch the curve, I literally just mean sketch it. Like you're not making a table, you're just literally sketching what growth versus decay looks like. So to figure out if it's growth or decay, you're looking at the base, and people get confused when they see a number out front. The number out front is either a stretch or compression. It has nothing to do with whether the function is growth or decay. What you're looking at is the base, and the base is always the one that the exponent is directly attached to. It may or may not be in parentheses, so don't let that be an indicator, but always find the exponent, see what it's attached to, and that's your base. So here the base is 5, and whenever the base is something above 1, then it would be exponential growth. All right, so sketch literally means sketch, meaning that a growth function looks like this versus going and doing the opposite behavior. All right, number 4, we've got two functions here, two parts here. A, identify the parent function, and B, describe the transformations. So the parent function is always just the base raised to just an x. No multipliers, nothing else in the exponent, no constants added or subtracted from the back of it. So my base here, remember what I said up here, find the exponent, see what it's directly attached to. So my base is 4/5, and the parent function always has just an x, nothing else besides the base and an exponent of x. Okay, and then part B, we're gonna describe any transformations. So there's no multiplier out front, which means there's no stretch or compression. Up with the x, there's an x plus 2. So remember, addition actually moves left, which is kind of counterintuitive, but x plus 2 means you are moving left 2 units. And then there's nothing after, like there is here. If there was, that would be an up or down movement. So just one little shift, just left 2 units. All right, for our next set, the rest of these are graphing and identifying key characteristics. So we're gonna start off by doing number 6 together. So this, what you do is you figure out what the base is, so our parent function. So we are going to do a graph based on our parent function, which is just 3 to the x. So our base, remember, find the exponent, see what it's attached to. So we're gonna make a little table first based on the parent function. All right, so this we do always just kind of this standard table, and then we sub that in. So 3 to the negative second, and you can do decimals or fractions, whichever you prefer. 3 to the negative second, remember, is 1 over 3 squared, so that's 1/9. But if you prefer it in fraction form, you can always write 3 raised to the negative second. I'm sorry, and get a decimal form. So that would be 0.11. Or 0.1 repeating. And then if I do the negative first power, 3 to the negative first is just 1/3, but again, if you prefer decimal form, you could do 0.3 repeating. When I plug in 0, 3 to the 0 is just 1, 3 to the first is 3, and 3 to the second is 9. All right, so that, your parent function points, they never, ever, ever get plotted. Your parent function is just to help you plot the new function. All right, so works like this. I'm going to set up my new table for my actual equation that I'm supposed to be plotting. So if you look here, we've got 2 transformations happening. This one right here, the x minus 2, all of my values are going to move to the right 2 units, and then the minus 7 on the end, all of my values are going to move down 7 units. So moving to the right 2 will affect my x values. So I'm going to take each of these values and move them to the right 2 units. So if I take negative 2 and move it to the right 2 units, it ends up at 0. And if I take negative 1 and move it to the right 2 units, it ends up at 1. So you can see where this pattern is going. It's going to look like that. All right, so I moved all of my x values to the right 2 units. Next thing I'm going to do is move my y values down 7 units. And this is where it wouldn't be the worst idea to have a calculator. So if you had this value, the 0.1 repeating, and you moved it down 7 units, then you get negative 6.8 repeating. And then if I did the same thing with 1, if I had this 0.3 repeating, this value, and subtracted 7, I end up with negative 6.6 repeating. And then the rest of these are easy. So 1 minus 7 is negative 6, 3 minus 7 is negative 4, and 9 minus 7 is 2. So this, you never ever plot these points. These points are just used to create this table. This is the value, or these are the values that you use to plot. So 0, negative 6.8 repeating. So I'm going down 1, 2, 3, 4, 5, 6, almost to 7. So really, it'll be hard to tell that you're not touching the 7. 1 is at negative 6.6 repeating, so just the tiniest bit higher. 2 is at negative 6. 3 is at negative 4. And then 4 is at 2. So you can see the exponential growth happening. It's getting very large very quickly. One thing I want to do is I'm going to write the domain and range first. Every exponential function has a domain of all reals. And then the range is based on this value right here. All right, so that graph starts at a value of negative 7 and then it goes up from there. And this is something called a horizontal asymptote. Your graph will never actually hit that point. So it's y values that are strictly above that value of negative 7. They never actually touch that value of 7. It's just going to get really close. So what we do is to finish off our graph, we put a little dotted line at negative 7, use that to guide the shape of our graph, and it will look like that. All right, so we got domain and range, our end behavior. As x approaches infinity, so as my function moves to the right, the values go, and you can see this arrow, the values go up, so that would be positive infinity. As my arrow goes to the left, so that's this graph right here, what my function is doing is it's approaching that dotted line, and that dotted line has a value of negative 7. All right, so my y-intercept, that is where I cross the y-axis, and I cross the y-axis when my x-coordinate is 0, so you can just pull that off the table. When my x-coordinate is 0, my y-coordinate is negative 6.8 repeating. And the asymptote I just talked about, that's that dotted line, and that has a value of negative 7. That's the line that we'll use to guide our graph, but it won't ever actually cross through it.